All right, on our first section, we need to state if something is a linear function or not. So let's start with number one, good place to start. So for a chart, you got to see if the change is constant. Well, we do have a constant change here. We have +5 and +5 and +5. And we look like we're good to go. But remember, to be a function, your x's have to be different. So no, this is not a function. This is not a linear function because it's not even a function. Let's go to number two. Have y equals 3x plus 4. Well, if you ask me, that looks an awful lot like y equals mx plus b, which we know that is a formula for a linear function. That's our slope-intercept form. So yes, that is linear. All right, let's look at number three. Well, it's a function, passes the vertical line test, but is it linear? No, this is not linear. Linear means we have one straight line. We got two straight lines, we can't do that. This is not linear. How about number four? Well, 4 is a function. It passes the vertical line test, and it does have one straight line that is not vertical. So yes, that is linear. Okay, number 5, we got x squared plus 3x minus 7 equals y. This cannot be linear because notice we got x squared. So that is actually quadratic. Ooh. In case you're wondering, that one's quadratic. So not linear, it's quadratic. All right, number 6, I would rather see this in a chart form, so I'm going to rewrite it as a chart. I'm going to write my x's and my y's. This is going to be itty bitty teeny tiny chart. I've got 2, 6, 0, 8, negative 2, 10. Hopefully you can see that. So again, I have 2, 6, 0, 8, negative 2, 10. So let's look. Going from 2 to 0, we add 2. Going from 0 to negative, we subtract 2. Going from 0 to negative 2, we again subtract 2. That looks good. Going from 6 to 8, we add 2. 8 to 10, we add 2. So notice we add the same thing for all of our x's. We add the same thing for all of our y's. So yes, this is linear. And no, you don't have to add the same thing on both sides. Just look at it one side at a time. Added the same thing here, added the same thing there. We're good to go. Next section. On this next section, we got to find the x-intercept, the y-intercept, and the slope. And for some reason, we got a random m here, so you can cross that out. All right, on a chart to find the x-intercept, remember that the x-intercept is where y equals 0. The y-intercept is where x equals 0. I know, confusing. And remember, our slope is m. So on a chart, we need to figure out where would y equal 0. Well, let's look. We got 8, 6, 4, 2. So the next number in this pattern will be 0. Well, let's see to see how we're changing. So to go from negative 1 to 1, we added 2. 1 to 3, we added 2. 3 to 5, we added 2. So if we add 2 to 5, we get 7. That means my x-intercept, where y equals 0, x is going to equal 7. Okay, what about the y-intercept? We want where x equals 0. Well, that'd be somewhere between negative 1 and positive 1. In fact, it'd be exactly halfway between these 2 points. So we would have to add 1 here, we'd have to subtract 1. So halfway between 8 and 6 is 7. So it happens to be our y-intercept is also 7. Okay, to find the slope, we need to find how, we need to put our change in y over change in x. So delta y over delta x. So to go from 8 to 6, we subtracted 2. To go from 6 to 4, we subtracted 2. 4 to 2, subtracted 2. Okay, on the x's, to go from negative 1 to 1, we added 2. To go from 1 to 3, add 2. 3 to 5, add 2. So that means our change in y over change in x is negative 2. Make sure to put your change in y over your change in x over positive 2. Well, that's not very sloppy. I mean, that is very sloppy. Whatever. I'm tired, y'all. Okay. Negative 2 over positive 2, that's the same as negative 1. So that's our slope, negative 1. All right. Let's look at this graph, number 8. Okay. Thank goodness it is much easier to find the x and y intercept on this. So the x-intercept, look at your x-axis. See where the graph crosses it. That'd be right here at negative 2. Y-intercept, same idea, but with your y-axis. Look at your y-axis. We cross right here at 4. To find the slope, we need to find 2 points and see, look at our rise over run. So reminder, rise over run, that's our slope. Well, I'm just going to use my x-intercept and my y-intercept. So from here to here, let's see, I went up 1, 2, 3, 4. So I went up 4, and I went over 1, 2. So my slope is 4 over 2. But I can simplify that. That's 4 divided by 2 is 2. Okay? Slope-intercept form, remember that's, I'm going to write down here, y equals mx plus b. That's the form they ask for us. So we're going to write y equals, our slope is 2, so we got 2x. And remember, b is the y-intercept, so we need to add 4. Let's move on to number 9. Okay, number 9. Ugh. I don't like standard form, but we got to do what we don't like sometimes. So remember, standard form is ax plus by equals c. And remember that the slope, when given the standard form, is negative a over b, which here our a is 3, so negative a is negative 3. Our b is negative 4, so we get negative 3 over negative 4, which is really 3 over 4. So we got our slope. Yay! Unfortunately, finding the x-intercept and y-intercept is a little more complicated. So again, x-intercept is where y equals 0. So that means we need to look at our equation and set y equal to 0. That means we just ignore this minus 4y. So for the x-intercept, we just rewrite, we get 3x equals 8. And to solve that, you got to divide both sides by 3. That'll give us x by itself. So then we get, this cancels out, we get x equals 8 over 3. That's our x-intercept. For y-intercept, we need x to equal 0. So we write negative 4y equals 8. To get y by itself, divide everything by negative 4. Alright, that means we get y equals 8 divided by negative 4, which is really negative 2. So our y-intercept is negative 2. Whew, that took a couple of steps, huh? Okay. 10 and 11, we got to write it in slope-intercept form. So remember, slope-intercept is y equals mx plus b. So when they say to write an equation in slope-intercept form, what they're really saying is solve for y. So we want y all by itself. So to do that, notice how we have positive 5x plus 3y equals negative 6x, equals negative 6, pardon me. To start to get y by itself, we need to move 5x. To move 5x, we need to subtract 5x from both sides. Okay, on the left, 5x minus 5x is 0. So we got 3y equals. And ask yourself, can we combine negative 6 and negative 5x? Heck no. They are not like terms. Please do not combine them. So you end up with this, negative 5x minus 6. Ooh, we're really close to having solved for y. To solve for y, we need this coefficient to be 1. Well, to get that coefficient to be 1, since we're doing 3 times y, the inverse operation is division, so divide everything by 3. And unfortunately, I'm going to have to write this to the side. So 3y divided by 3 is just y. Negative 5x divided by 3 doesn't get much simpler, so I'm just going to rewrite it like that. Negative 6 divided by 3, we can simplify that to be negative 2. There's our answer. On to number 11. Ah, thank goodness. They gave us the slope, but they did not give us the y-intercept. So this is going to take a few steps as well. We're going to write everything we know in the slope-intercept form. So again, remember it's y equals mx plus b. So y equals, our m is negative 3, so negative 3x plus b. But hey, they gave us an x and a y. Remember, this is always x comma y. So let's plug in this for x and this for y. So we get negative 1, because I got it from there, equals negative 3 times 2. And we still have no idea what b is. Our goal is to find b. So to solve, we need to deal with our parentheses. Negative 3 times 2 is negative 6. Then, since we're solving for b, we need b by itself. Since we have negative 6 plus b, to get b by itself, we need to add 6 to both sides. Okay, negative 1 plus 6, that's 5. Negative 6 plus 6, that's 0, so 5 is b. We now have everything we need to write it in slope-intercept form. So we end up with y equals, our m is still negative 3. We need y equals mx plus b, so here's our x, and our b is positive 5. Whew. I'm getting tired. I don't know about you. On to number 12. We need an equation in point-slope form. Remember, point-slope form. You can look at our poster near the door out of our classroom. Looks like this. Y minus y1 equals m times the quantity x minus x1. And good news, they gave us a point. They gave us the slope. So we can easily put it in point-slope form. So we need y minus. Okay, our y1 is negative 6. I'm going to put that in parentheses. You'll see why in a moment. Equals m. M is slope. So our slope is negative 2/3. Times x minus our x1 is 4. Well, here's why I put this in parentheses. We need to see that we have a negative 6, which is really negative 1 times negative 6. That's plus 6. So we end up with y plus 6 equals negative 2/3 times the quantity x minus 4. That is point-slope form. Near the end of the front. Whee! Okay, I'm going to switch to my pencil. I'm tired of my blue pen. Okay, this table shows the price of a video game for different years since the game was released. We need to find where the price decreased at the greatest rate. So we are looking at slope. That means we need to find the slope between each of these points. So first, let's find the difference between these years. And keep in mind, years is going to be our x, our price is going to be y. Well, going from 2000 to 2002, we have plus 2. Going from 2002 to 2003, that's plus 1. Going 2003 to 2005, that's plus 2. And 2005 to 2007, that's plus 2. So we found our changes in x. Let's find our changes in y. Going from $58 to $54, that's minus 4. Going from $54 to $50, that's also minus 4. Going from 50 to 44, that's minus 6. And going from 44 to 43, that's minus 1. Now we got to look at all our different slopes. So I'm going to do a little squiggly line. And again, remember our slope is the change in y over the change in x. So our first two sets of years, we have -4 divided by 2. Okay, our second one, we have -4 divided by 1. Our third set, we have -6 divided by 2. And finally, we have -1 over 2. Well, we got to simplify a couple of these. So -4 over 2, that's -2. -4 over 1, that's -4. -6 over 2 is -3, and then we have -1/2. So comparing these numbers, we have -2, -4, -3, and -1/2. -4 is our greatest rate of change. So our greatest rate of change was here from 2002 to 2003. Whew, that one took a lot of thought. Okay, on to the last few on this side. We need to find the domain and range for each of these graphs. Good news. We start out with a really simple one. So remember, don't forget our Dixie-roid. So domain is looking at x's, range is looking at y. Good news, if you have a straight line and it's not horizontal, it's not vertical, it's at some slope, and it goes forever in both directions. So notice we got an arrow on both ends. Then our domain is just x is in the set of all real numbers. And our range is similar. Y is in the set of all real numbers. Yay, that one was easy. 15 and 16 take a little more thought. So let's start with the domain. Let's see, I'm going to write my domain, you know what, I'm going to write my domain over here for 15 and the range. Okay, so domain means we're looking at our x's. So look at this axis. So we look and it starts, I'm going to use some color. Here's where it starts, and notice this line never ends on this end. So that means our smallest value for x is 0, and it just keeps on going forever up. So that means x has to be greater than, could be equal to 0. So x is greater than or equal to 0. Okay, let's look at our y's. So y is this axis. Notice we start right here, and again we go forever up. So it starts at 40. So y can be greater than or equal to 40. And the reason why we know it could be equal to is there's not an open circle here. If they had an open circle, that'd be different. All right, number 16. 16 is a little tougher. In fact, I'm going to give myself a little more room to write the domain and range on 16. Okay, again, domain has to do with our x's. So we're going from here to here on the x-axis. It might be hard to see, but that number right under there is a -4, and that number here is a 2. So that means x has to be between -4 and 2. But notice we have an open circle here. So that means we have -4 is less than, not equal to, x, which is less than or equal to, because we have a solid dot here, 2. Okay, for our range, let's draw a line over to our y-axis. And they were tricky. They labeled this line as 2 and this line as 4. Well, this looks like it's halfway between our origin and 2, so that means this must be 1. That means our range must be between 1 and 4. And we cannot be equal to 1 because we have an open circle, so 1 is less than y, which is less than or equal to 4 because we do have a solid dot there. All right, let's go on to the back.